Welcome to class 3 of machine learning. I'm 100% sure by the end of today's class, you will have no confusion in confusion matrix. We'll continue from the last class. This is class 3. Now, specially I made this diagram for you so that you will be able to not only understand, you will be able to retain it. And it will be easier for you to see this one and to get this properly. See here, I selected a basket where I have apples and oranges. Two things here. Two fruits I've taken. And this is called classifier. I have so many classification algorithms. You will come through those. Maybe 12 of those we will be doing in this course. Classifier means what? We'll write an algorithm. Okay, we'll train. And then finally, it will divide, it will classify. After training, it will be able to classify apples and oranges. If you have a baby 2 years, you teach her or teach him that these are the apples and these are oranges. Again, you might have a question if you are new to machine learning, how to teach. Obviously, because they can use their eyes. When I say classifier and algorithm, it can see. Baby can see and remember. So how baby remembers? If you go deep, then also you will be able to know something in details. Maybe using the shape, color, there are so many. These are called features. Feature selection is a part of machine learning. So whatever way a baby can learn through algorithms, you keep an agent or whatever, you just directly apply the algorithm, it will be able to divide into two parts, the apples and oranges separately. But there might be a problem. Even if a baby can see, we can see, sometimes we make mistakes. So there is a chance of mistake. And I'll tell you what is the difference of this diagram with the last one. I've written all here, 100. All. Out of that, if you check here, 45 plus 30, these are exact. I can write here as well. I considered 55 apples. I can write this side. And 45 oranges. These are apples. And in total, we have 100. Out of this 100, we want 55 here, 45 here. But whatever classifier, whatever algorithm we use to classify, that is called a classifier. The classifier was able to pick 45 apples correct and 30 oranges correct. And wrongly, the 10, they should have been here. They came to this side. This 10 came to the right side. They should have been here. And oranges, they came here. These oranges, they should have been here. However, they were classified this way. So there is an error. So if you see the total error, 45 at least you got properly. Now at this point, you need to decide what is positive, what is negative. There are only two. It's a binary classification. We are using a binary classifier. Because there are two, one you can say positive, one you can say negative. Almost 50% of the students, once they see this kind of a thing, invariably they ask, what is positive, what is negative? Positive is something you want to give importance, you want to make the subject. So if you say this is your positive, this is your negative. Positive negative concept is only there in a binary classifier. If you want to classify into two parts, then positive negative stuff will come. Otherwise, you'll have 3 or 4. Will not be able to write positive negative. One of my students asked me, in IRIS data set, we have 3. If you see this one, we have 3 here. One is Setosa, then versicolor, virginica. If you take this as positive, this is negative, what about this? This was the question. That's why I'm saying in a binary classification, you can write positive, negative. So I've considered apple to be positive here and orange negative. The other one is negative. Now we'll fill here actual 55. I'll write 55 here. 45. They were mixed up, and whatever classifier we used, that classifier was able to predict 45 properly. So let me write positive negative here instead. You can write positive or directly you can write apple. Actual I've written already. Then orange. Here you write apple, orange. Now the 45 I mentioned, I'll write here. Apple, apple. That means this side we wanted for the positive apples. For 55 we wanted, but we got 45. Whatever classifier we use that predicted 45 properly. So this way, this is actual and this is predicted. Predicted number of apples 45, and there were 45 out of 55. 45 were apples and 10 were also apples, but they went this side. Okay, so we'll manage this one later. Let's take this one and this one first. In the second one, if you see 30, there are 30 oranges, more than 30, 45, but 30 oranges, they came to this side. So orange actual and predicted also orange. So 30, 45. So when we say accuracy, it's a very simple one. 40, 30, 70. 75 divided by 100. The total is 100. So that is 0.75. However, we don't depend on accuracy because this is the overall result. Now, when we talk about precision and recall, we don't use the whole total. We see here. Now, let's come to precision and then recall. Before going to that, let me fill other two. Actual was orange. Actual was orange. 30 over already. You have another out of 45 with 15. That 15 orange that came to this side. So where I need to write 15, here or here? Anyone who can answer? The 15 orange, actual orange is still there because 30 classified properly. The 15 actual orange predicted by the model, by the classifier, as what? Apple, because this is apple side. Let me write, this is apple side and this is orange side. And instead of writing here, let me write here. This is positive. This is positive and this is negative. So we wanted all apples to be this side and all oranges to be this side. But the classifier made mistake. 15 apple classifier brought this side. This is the problem. So 45, 30, there is no doubt that is the main diagonal. Even for 3 cross 3 also, that will be the main diagonal. Now these are the two errors here. So you can say this is true positive. All are positive here, not actual, predicted. Okay, the classifier predicted this way, all positive, but this is the real positive, the positive ones, or you can say the apple ones. These are the real ones, actual ones, and the predicted ones. So correct, you can say. Okay, this is true positive. This one, the first one, 45 here, true positive. What about this 30? This is true negative. True negative means these are the oranges, negatives, and classified also negative. That's fine. This is also fine. 45 plus 30, 75 fine out of 100. This is over. Now let's go to the error part. If you consider the error, there are two errors here because it's a 2 cross 2. Now this 15 classified by the classifier as apple. This is positive apple side. Okay. According to the classifier, this is apple. but we can see in our eyes this is not apple, this is orange. There is a problem here. So 15 should go here or here. What is actual this one? Orange, right? We can see at least in our eyes this is orange, actual orange, but predicted by the classifier this side means apple side. Okay, so actual orange predicted apple side. Okay, so you see predicted apple, predicted this side apple, but actually it's orange, so we'll write 15 here. What about 10? Orange side, classifier said this right hand side is orange and left hand side is apple. So classify, according to classifier, this is also orange, but we can see that this is not orange. There is a problem. Actually, these are apples, but classified as oranges. Actually, apple classified this one orange. So we'll write 10 here. Now, these are the problem. 15 and 10. These are the problem here. So we got this one. Now, when you find precision and recall, when we talk about precision and recall, we are talking about only positives here in 2x2 binary. You can do it for negatives also. After overall accuracy, precision for positive, precision recall for positives. We are finding for positive. So this 45 will be constant. The only thing you need to remember is, I'll write 45 here as well. Because the precision and recall we are finding for apple, only for positives. For negatives, if you want, you can find it separately, similar way. We are not finding here. The only thing you need to decide is the second one. Remember row and column. 10, 15 you have to use. Here you have to write 10 or here you have to write 10. That is the only thing you need to remember here. Now what happens is, when we talk about precision, in precision what happens, you have to see the side. Okay, which side? The classifier divided into two parts. According to the classifier, these are the apples. So what percentage is really apple? That is your precision. Okay, so I'll write 15 here. So remember, what is precision? Once again, whatever way the classifier, whatever algorithm we used here, and whatever classifier, we have names also, we'll use by names in subsequent classes. The classifier was able to predict 45 apples correctly, but it made a mistake for 15. So what is the percentage? It's more than 50%. We can understand, because 45 out of 60, right? So let me write 45 out of 60, whatever it is. However, when we talk about recall, again, remember, I am doing only for the left hand side, positives. This is positive side, apple side, positive. I'm not doing anything for orange here when I talk about precision and recall. Precision for positive, precision for recall. So now we'll see this way, this one here, this way. And here, if you see here, this way. So you can remember logically. It's easy for you to remember. You see how many apples are brought to the apple side, okay, from the actual number of apples. So actual number of apples, you had 45 plus 10, 55. Last time I used one diagram. I like the books or something like that. Okay. So there what happened is, that diagram was also good, but then the total was not mentioned. Okay. So if you need one diagram where you can understand fully, this is the diagram, I think. Okay. And you see, out of all apples, 55 apples were there initially. 45, the classifier able to correctly identify. Okay. So what happened is, out of 55 apples, this classifier predicted 45 correctly. Okay. Out of 55, 45. If you write that, that is your recall. 40, this will be 45 divided by 55. However, precision is whatever the classifier predicted. Okay, out of that prediction, like classifier said these all are apples, but there is a problem here. Okay, so what is this percentage you have to see. Now if you see the percentage from this, out of all actual apples, how many apples are there? Out of all predicted apples, how many apples are there? Apple is my subject here, positive. So how many positives are there out of actual positives? How many positives are there out of predicted positives? Classifier predicted all these as apple. So these two things you need to find. And through different examples, you will be able to follow if you understand this properly. Okay, let's proceed further. So remember this way, when we talk about actual apples, okay, then we will say recall. Precision is something from the predicted. You can remember this way also. Precision starts with P and prediction is also P. Out of predicted apples, according to the classifier, these are apples and these are oranges. These are positive, these are negative. So out of predicted apples, predicted positive, how many are positive? How many are apple? Okay, that is P. P they are matching. That way you can remember. Recall means actual. Out of actual apples, how many were apples by the classifier? That's all. So this divided by whole, this divided by this. That way you can remember. And then finally, when you find F1 score, again you might ask why F1? We have formula for a beta score. We'll not go through those mathematics. It's not required here. We'll not go much through algorithms. We'll not go much through the mathematics statistics as well. Because if you go through Python programming, it's like a C. It's not required because Python is a general purpose language, unlike R programming or something else. It's a general purpose programming, means anyone can use. People that are working in banks, people that they're Python developers, people they are doing data science AI, people they are doing some other stuff also. Everywhere we can use. So we'll not go deep and bring everything here. Whatever is required, that you need to do. Even will not go to this F beta score. If sometimes it will come, you will see F2, F3 and all that. There is a general formula, but we use F1 score here. So the formula is 1 divided by 1 by 2 P plus R, or you can remember 2 PR divided by P plus R. This is the simple formula you can remember. Harmonic mean you have to take between two rates, you will get another one. This one you will see in the output. I'll show you that. Even all this you will get in the output, but people they accept and they continue without understanding what are these. Now, for a drilling work or revision, you can say, I've done this one also. Another example for you. Here what I did is boys and girls, the mixed up. Now classifier using the features, whatever way you would like to differentiate between boys and girls. I've taken this from the, word file only. These figures. Classifier has to predict boys and girls using features. So what happened is the classifier was able to predict these many properly and girls. So how many boys are here? I don't remember. 1, then 2, 3, 4, 5, 6, 7, 8. Okay, so let me write 8 boys here, and there are 15, 5 into 3, so 7 girls are there. Okay, so boys and then girls. You can take anyone positive, anyone negative, it depends on you. Now out of 8 boys, 1, 2, 3, 4, 5, 5 here, 5 here. Okay, so 5 are classified correctly and 5 are classified correctly. According to the classifier, this side you can say, this side is the boys side according to the classifier. Okay, or I can say positive side, and these are the girl side. Okay, negative side. So now what will happen is classifier thinks or predicted, you can see that these are the boys, okay? So, but I've written separately because you can understand there is a problem here. And then according to the classifier, these all are girls, but these three are not girls. That's the problem part. So we'll try to fill this one. You write actual here, predicted here, then also how it should give you a problem. If you're able to understand this diagram, from this only you have to write here. So sometimes you will see actual here, sometimes predicted here. You should not create a problem. Even if I write numbers like 5, 10, 2, 3, I'll write. If you change sides, you change according to this one. You numbers also. These two numbers, if you write actual here, you write here. If you write that, these two will not change because they are matching things. These two will not change. The only thing you need to change is in 2 cross 2 at least, 2 and 3. You swap 2 and 3, then sides can be changed easily. Okay, let's not worry about that. Let me write here. Actual, we started with this, and then predicted by the classifier. Again, if you are asking why we're finding these matrices and all, it's a classification task. We'll see how many incorrect are there. In a classification task, you have to know how many are not correct. If you are using a regression, you can use so many residuals and all those you can use. For classification, we use this. Now, for regression, why we can't use this way? Who can answer? For regression task, why we can't use this way?
So because the data is not discrete.
Yeah, because if you have a straight line, then you predict something that's a continuous one you are predicting in regression. What will happen is there are infinite number of possibilities. You can't write in this way. In classification, you are classifying, so you will be able to write, okay, 2 or 3, 4, whatever. Okay. Now, you tell me the numbers, actual boys, okay, and predicted boys and girls. You tell me the numbers, I will write. Anyone now?
5325.
Here 5.
Then next to it 3.
Okay, they are actually
25.
boys, and then the classifier predicted girls. Okay, 3.
2, sir. The actual was girl, but it predicted.
See, predicted boys. Okay, predicted is boys. 2 predicted boys. Okay, these two, but they're actually
Girls.
girls. Okay, fine. So 5.
So then 5.
Yeah. Then accuracy means total. I mean total accuracy you can find from this total 5 plus 5 10 divided by whole is 15, right? Yeah, then precision and recall. What is precision here? Again, positive 5 you write here, 5 you write here. Then here I need to write, what I will write, 3 or 2?
2, sir, in precision.
In precision 2, are you sure? Remember, whatever you predicted, out of that, what is the percentage you are correct? Whatever you predicted as boys, according to the classifier, these are boys. So out of that, what percentage is correct? 5 by 7. But actual number of boys, if you see, these were actual boys, okay? Then you take mean, you will get the final one, F1 score. Yeah. Now 3 cross 3. How many are there in total? Total we have taken here Let me write the numbers. They're mixed up. Three fruits here. I've taken apple, orange, and lemon. Okay, these are the three. In total, if you see the actual side, in total, how many apples are there? Actually, 4 plus 1 plus 5. 4, 1, 5, 1, 6 apples are there. Okay. And oranges, actual oranges, 6 plus 2 plus 2, 10. Lemon, if you see, 3 plus 0 plus, this is again 9. 25. We have 25 in total. Classifier has to classify in three different groups. The group names we know. We can say something positive, negative here. So how we'll manage here, you will see. We'll check whether these are right or wrong. Now, listen carefully. No positive, negative here. We have apples here. Okay. So these many apples, whatever it is, they were classified correctly. Let me separate into groups according to the classifier. These are apples. Okay. According to the classifier, these are apples, these are oranges, and these are lemons. 3. Now, when classifier says these are apples, okay, we'll check that, okay, these are correct, okay. This classifier correctly classified how many apples? We have to see this one, 4 here. Let me write the number here, 4. And how many correctly classified oranges? 2 here. 4, 2, and 6. 6 lemons, okay. So these are classified correctly. However, these are not apples we know, but according to the classifier, these are also apples, okay. What are the mistakes here? These are predicted as apples, but these are not apples. So predicted apple, you see predicted apple, this column. How many are there? 6 and 3. So 6 came from which side? Actual orange side. 3 came from actual lemon side. So what happened is only 4 out of how many here apples? How many actually apples are there? Okay, 6 are there. 4 correctly classified, but brought so many other stuff. Okay, we had only 6 apples. Okay, the 2 apples they went there. We'll see where they went. The 2 apples. The 2 apples they went to orange and lemon here. Classifier said, okay, this looks multiple. Okay, I didn't see properly, but remember this is one only. One apple came here, one apple came here. 4 4 plus 1 plus 1 6. Okay, out of oranges 2 are here, correct, but 6 went to, unfortunately, to, these are oranges. See, actual these are oranges, but classified as apple by the by the classifier. Okay, 6. So the 6 will go to apple side. Okay, this is 6, correct. Then 2 actual oranges, but they came to the lemon side. So this is 2. Okay, now lemons, 3 lemons are here. Why I wrote 6 here? 3 are here. Actual lemons are here. Then 0 went to this side. 6 went to lemon side. Okay. I have to see this way. Correct. 6 are lemons. Okay, this way we have to see, right? Diagonal, the last diagonal. Then 3, 0 are the problem. 0 means nothing. 3 went to, 3 actual lemons went to apple side. Okay, so 3 went to apple side. So if you see lemon here, finally 6 here, nothing, 0 here, 3, 6 plus 3 9, total 9 here. And apples you see 4 1 4 1 1 6 over. Then oranges correctly classified only 2. Then orange here 6 6 to 8, 8 here to 10. Okay, 10 oranges. Now when you find accuracy, suppose you have to say accuracy for positive, negative. We don't have positive, negative. So accuracy for apples, you can say. Here, see, class we have written. The class thing was not there. Last time I didn't talk about this classification, right? So for apples, when you find precision recall, how can you find? Now, again go back to the original formula, because according to the classifier, all are apples. How many are correct? You have to see. 4 divided by 4 plus 6 plus 3. So when you find precision, you will get 4 divided by 4 plus 6 plus 3. 4 divided by 13. For apples, I'm saying only. Okay. I'm considering only the first group. For apples, what is A and what is P? P I got a total accuracy. If you find in accuracy, we don't see any group. Total how many correct? 4 plus 2 plus 6. 12 correct out of 25. So 12 by 25. Everything we see. Less than 50% here. Accuracy score. This is not good. Okay. Now, this is also not good. Apple, if you see, I mean, sorry, this is precision, this is recall. When you find recall here, now how many actually apples are there? 4 plus 1 plus 1, 6. Out of 6, it brought apple 4 already. So that way, if you see 4 divided by 6, you will get, okay, 2 divided by 3. This is good. You see recall here, 66.7%. This is good. This is good. 66.7%. This is only, precision is only 30%. 4 divided by 4 plus 6, 10 plus 13, 4 divided by 13. This is around 30%. Precision is not good. Recall is good. At least better than accuracy, whole accuracy. Now you go to orange. This we didn't find. We found only up to this. Even we can find F1 score here. The harmonic mean you have to take. Orange and lemon we didn't find. If you see here, we termed one is positive, one is negative. So when we talked about precision and recall, only for boys we find here. Remember, we found only for boys, because we have taken boys as positive. Even if I've not written positive, negative here, I've not written, then you can go to this one. Even if you have any doubt, you can clarify here. See here, when I talked about positive, one class positive, the other class negative, total positive, negative, that way. However, here no positive, negative. Here there are 3. That's why you have to write separately. But in the binary classification, the first one, we wrote only the first row. We never tried to write the second and third row. If you want, now you can do everything for the second class as well. Now, accuracy will be same. Precision recall we found for positive class. Positive class means for apple group. Apple class we found. If you want to find for orange class, see, my subject is 5 here. Now the subject will be 3 here. Okay, in that case, it will be 3. 3 divided by, this way you have to divide, this way you have to divide. Here also, if you go, for apples, we found these 2, these 3. For oranges, if you find, you have to consider 30. See, 30 I have not written, 45, 45 I have written. Okay, 30 divided by 30 plus 10, 30 divided by 30 plus 15. That way you have to write. Now, because here anyway we don't have 2 classes, we can't leave one class. There also it's better you write for the other class. Even you don't need to say positive, negative. You say apple class, orange class. They present it that way. I mean, everywhere in data science, they make things complicated actually. It's not that complicated. You see, this is so easy. So after finding for orange and lemon, orange, how can you find? Now, how many oranges are there? 2 oranges are there. Okay, so the classifier says these are orange. So according to the classifier, all are oranges. How many predicted correctly? 2 out of 3. Okay, that is your precision. Recall when you find, if you can recognize that these are oranges, and these are oranges. So out of actual oranges, how many oranges it was able to bring here to orange class? Okay, so 2 divided by 2 plus 6 plus 2. That's what you need to find. That way for lemon also you can find. Then F1 scores, I have written here. F1 scores easy. Just harmonic minimum, these two. You find, you write here. Now, when you use Python code, again you have to use sklearn. I'm talking about sklearn because most of the things, 90% here in data science class, we'll use sklearn. Then in AI, either we have to go to TensorFlow or PyTorch. Now, macro F1, macro precision, macro recall. So you just take the mean, that's all. Normal mean, no harmonic mean. Precision, okay, apple, orange, lemon, 3 rows we have. Now we have written though this one, 42, 30.8, 66.8. This is macro F1. Macro F1 means this is a kind of average. Okay, simple average you can say, not weighted average. So this plus this plus this. Why you were finding this? There is a reason. I'll tell you. Suppose you have 2 classifiers. From the next class, we'll start one by one. Suppose you study 12 kind of classifiers. 12 algorithms will study. They are 100% math and start. No coding is required. For knowing what kind of classifiers, how we are using classification task and all. Once you learn those, you have to apply. Then it will classify. Once it will classify, you will see, suppose you are using 3 algorithms, 3 different kind of algorithms. You can say 3 classifiers. We have classifier 1, classifier 2. According to classifier 1, we got this result. Then you see when you are using classifier 2, how you are getting results. Then you want to compare 1 and 2. How can you compare 1 and 2? Because you have so many things here. How can you compare? Three things here. Suppose classifier 1 gave these figures, okay? And classifier 2 gave these figures, here 40% less, here 60%, okay, here 40%, here 70% more, here 35%. So if you see, this is better as compared to this one, but this is better as compared to this one. So how can you compare one classifier? Suppose you need to choose a model to apply for classification task. Which classifier you will choose? It's difficult. So if you find the average, you can compare one number. 46.5% F1 score, macro F1. This is called macro F1. Macro F1 means simple average, that's all. Then we have a weighted average also. So simple average you find, so that you will get 1 numbers. Okay, it will be very easy for you to compare. 1 number you will compare. Okay, 3 things you need to compare. Not 3 things actually. This is one. F1 is sufficient because in F1 these things are already there because you got F1 from these 2, right? So these information are also there in 1. So even if you compare these 2, that is fine. Individually, if you want to compare, you can compare. You don't need F1. You can compare this or this and this. Okay. And there are cases where you would like to compare these 2 rather than these 2. I'm not going to that now again. When things will come, you will be able to know. However, in general, I'm saying you can compare only F1, macro F1 or weighted F1. Now let's go to the second one, weighted F1. Weighted F1, when we say, you have to weigh 6, 10, 9, remember, by total 25. This is summation Wi Fy divided by summation Wi. That formula is there. Okay. So when you find in actual science, time weighted rate means the weight should be time. Okay, money weighted rate. So how you will weight, that is also important. We'll weight according to the classes. Okay, the number of classes. So whatever numbers you had, 6 here, 9 here, I've written, if you see 6, 10, 9, okay, those weights you have to write here. So instead of 3 here, weights are 1, 1, 1. We've given equal weightage to mathematics, you can say science, and some other subject you are studying. Equal weight, okay, 1 hour, 1 hour, 1 hour you study. Sometimes you don't want to study that way. You study more mathematics because you have to solve problems. Do science less, okay. If you give weights, then that will be a bit different one, okay. Here we have not picked equal numbers, so whatever number of apples, oranges and lemons you picked, that way you have to find. That is weighted average, 46.4%. That is simple average, that's all. Weighted precision, weighted recall. Now if you want to see, though I'll not discuss the Python code here, see how many lines of code you need to write Python code to get this. From sklearn, those who are new, for them it must be new. From sklearn import matrices, so you can't, I mean everything will be in one line, because I pasted here, it came this way, and this is anyway has any there, this is a comment, forget about this. This is one line code. sklearn will use extensively, you will be able to know sklearn. I'm not going to that now. Matrices is what you need to, this is constant, okay. Again, no intelligence. If you know, you are learning Python, you know it. So when we do the implementation, we'll use this one from sklearn import matrices, okay, that you need to write. Then this is one line. C for apple, whatever these things you can write. AOL, okay. I mean, these are something you need to write, that's all. AOL, okay. And then true predicted, you'll be able to know when you are doing a model. Then see matrices dot confusion matrix, true predicted. Why we have written this way? Let's not worry about that, separately we'll do. And matrices dot classification report, okay. I'm not discussing this now. We'll do once we'll go to sklearn and we'll do a model and we'll apply. Now I want to show you the output here. Where is the output? Achha, I forgot to bring here. Okay, never mind. Just a minute, I need to check actually. Wait. So this way you will have to write. Now you will get whenever you do classification, okay. See, again, this is NumPy way of writing. Those who didn't study NumPy, that will come in 25th and 26th videos. NumPy representation, okay, this one, this is very important. Again, the implementation will happen using NumPy pandas. So 25, 26, 27, 28, sorry, 26, 27, 28, 29, 4, 30. If you want, you can do, I didn't send you, I mean new guys, 31, 32, 33. These 7 or 8 videos you have to do. This is NumPy, okay. And then see, cat, face, hand. The program was for these 3, okay. According to the diagram I've drawn, I've taken apple, all this, because I can bring here and there and all that I can write, okay, properly. So cat, face, it's difficult for me to bring all these. That's why cat, face, even in the coding, remember I showed you cat, face, hand written. So these are there from the coding part, okay. So in our case, because according to the diagram I have made, I've written apple, orange, and the third one is lemon, okay. So you get this way. Now tell me, you are able to match or not? These are the ones we already got, okay. These are the ones, precision, recall, F1 score, total 25, okay. So accuracy score 48. If you remember, it's 0.48. Even we must have found this one also, 0.48. And these are the ones micro weighted average. These even when micro also, micro, I mean, we don't require here. Total accuracy 0.48. Okay. And then it's here. I can show you why 0.48, because it was not able to predict properly. I must have said you 48% only. And macro and weighted is what we have done just now. Okay. And this is 3x3 precision recall F1 score. These things you will get. Okay. And this way you can store. For storing, you need NumPy, those who are new. And if you want to do some kind of analysis, for that, you need pandas. Okay, these are the two things required. And plus that, you need another one for visualization. If you want to see the graphs, for that, you need matplotlib. For that, another 5-6 videos, maybe from 40, 39, 40, 41, 42, 2 to 3 videos you need to watch. So continue doing those things. Meanwhile, we'll start some algorithm and we'll complete one by one. Class is over for today. Thank you.
Thank you, sir.
You need any concern or doubt, you can ask me before I leave.
Sure, sir. Thank you.
Okay, all right then.